Good day, everyone. My name is Siddhartha Konda, and I will be presenting on the topic CMOS image sensors. So, what are we going to learn in this presentation is this is a small overview. What is a CMOS image sensors? As you know, we'll like to learn that. What is the importance and the impact of CMOS image sensors in the current technological field? And there is another image sensors known as CCD, which is charged coupled. There are also an image sensors, but we will be learning what are these differences and why CMOS is preferred more than CCDs. And we'll be learning about the working of the CMOS image sensors, where first we have to learn what is CMOS technology and the applications of CMOS image sensors, where we most of you may know that CMOS image sensors are already used in many cameras and smartphone cameras. But are there any other applications of these image sensors? We will be learning in this presentation. So first, what is a CMOS image sensors? Well, CMOS image sensors are a complementary metal oxide semiconductors. This is a type of semiconductor technology inside some or many digital cameras. It consists of an integrated circuit that records an image. You can think of the image sensor as being similar to the film in an old film camera. The CMOS sensor consists of millions of pixel sensors, each of which includes a photodetectors. As light enters the camera to the lens, it strikes the CMOS image sensors, which causes each photodetector to accumulate an electric charge based on the amount of light that strikes it. Then the register camera then converts the charge to a digital reading, which determines the strength of the light measured at each photodetector, as well as the color. The software used to display photos converts those readings into individual pixels that makes up the photo when displayed together. Then importance of modern image technology. What is the importance of this CMOS image sensors in the current imaging technology? Well, it is a very fundamental component in many imaging devices where it's very small and lighter then so it can be used in devices like smartphones or drones. It has many integration functionalities where we can integrate with additional functions inside the sensor. It is vital for many portable devices and battery powered applications, and it can be mass produced and reduce the manufacturing cost, which is very helpful, and it enables high definition video recording and sharp photography irrespective of its size, which is very small. And compared to CCD, it has a better high definition video recording capability, and it captures a wide range of light intensities accurately and preserves the details in both shadows and highlights of the image, which is before the sensor. Now, what is its impact? What are the impact of CMOS image sensors in the consumer electronics? Are we using them or no? Well, first is the most common is the smartphone cameras. It is a very mainstream. Currently, the smartphone which you are holding, the front and the back cameras, the image sensors are being used, and it can facilitate advanced photography features like the HDR, the night mode, the other modes inside the camera app that you're using. It also facilitates those advanced photography features. CMOS sensors are also used in digital cameras. The DSLRs, the mirrorless cameras, they all use CMOS image sensors because it is a good innovation and it's lightweight. And whereas are we using, except for the cameras, is automotive imaging, the ADAS, advanced driver assistance systems use CMOS image sensors. And in medical field, we use CMOS image sensors for X-ray, endoscopy, and diagnostic imaging. These all use CMOS image sensors, and we also use it in industrial and robotics field, like for machine vision. It needs a good vision, so it needs good sensor to see the images, and it enables precise manufacturing processes as the image and the video quality is very high definition. So using these sensors helps in the manufacturing process. We also use it in the security and surveillance systems and even in the face recognition systems in the CCTV cameras. And so due to this, it enables public safety and also prevents many crimes. So what are disadvantages? of CMOS image sensors? Well, for the first, the power consumption is really low, which is a good thing. For the low power use, we are getting a high definition image or video, and it's very less cost when compared to other image sensors like CCDs. And inferior dark noise will get a higher reliability image. So in a dark mode or in a dark light areas, the image quality will be also pretty well. The camera size as small as the readout logic can be included in a smaller chip, and it's flexible readout because of the direct individual pixels addressing, which allows more storage bin and limited scene scan possibilities. And it has higher sensitivity in the near infrared region, and blooming is strongly reduced. And as compared to CCDs, the frame rates in CMOS image sensors are really high, and they produce really good HD videos, which is a good thing. Uh, and they're used in a lot of applications, and it has better performance when compared to CCDs or other image sensors. Now, what is the other type of image sensors present? The other type is the CCD image sensors. These are charge coupled devices. Now, let's learn what is the difference between CMOS and CCDs and why CMOS is preferred more than CCDs. Well, coming to CMOS, the structure of CMOS, it has pixels, and each pixel has its own amplifier and readout circuited. And in CMOS, the pixels are arranged in a grid pattern, with each pixel capable of individual capturing and converting light into electrical signals. And the operation is when light hits the sensors, each pixel's photodiodes, they are converted into from light into electrical charge. And the charge is then converted into voltage signal, amplified, and read out directly from each pixel. What are the key features of CMOS? It has low power consumption, and it has faster readout speeds. And the readout speeds are fast because the parallel readout from each pixel, and it has lower noise levels, resulting in cleaner images and on-chip integration where we can add additional features on the chip. And applications are, it has wide range of applications, and the technology is still growing in the market. When coming to CCDs, the charge coupled devices, the structure is in charge is transferred through the sensor from pixel to pixel in a single uh, amplifier. Each pixel and all the pixels in the sensors have the same amplifier, and it uses a bucket brigade architecture where charge packets are shifted sequentially across the sensor. What are its key features? It has higher sensitivity, lower dark current, and traditionally higher image quality. These are all when compared to CMOS. Now, coming to applications, uh, it's very used in professional and scientific cameras as it requires high quality and low noise images. And it is also used in specialized imaging applications where high sensitivity and imaging quality are preferred. Now, CMOS sensors are cost effective and lower power consumption and high speed imaging. Whereas CCD sensors, they excel in applications demanding high sensitivity and superior image quality and low noise performance. They but when compared to CMOS, they use higher power consumption and they have lowest readout speeds. While choosing between CMOS and CCDs depends on the specific application. So it is application related. If you are using for scientific purposes, it would be better to go for CCDs. But if the power consumption should be low and you need higher readout speeds, then CMOS is considered. But the CMOS technology is currently still increasing and advancing. So CMOS may also overcome these differences of CCDs and become preferred more than CCDs. Now, coming to the working of the CMOS image sensors, first we have to learn about CMOS technology. What is a CMOS technology? It is a fundamental building block of modern integrated circuits and microchips, and it is widely used in many digital and analog circuits due to its low power consumption, high noise immunity, and scalability. And in the CMOS technology, it contains the components of transistors And in the transistors, it has two types, which are NMOS and PMOS. NMOS for N-channel transist MOS, for N-channel MOS, which uses an N-type MOSFETs where current flows between the drain and the source. And PMOS is a P-channel MOSFET, which where current flows in the opposite direction, that is from source to drain, when a voltage is applied to the gate. So in the CMOS technology, these two types of transistors are paired in a complementary manner, where for every NMOS transistor that pulls a signal down, which is known as logic low, or pulls the signal down to the ground, there's a corresponding PMOS transistor that pulls the signal up to the supply voltage, which is known as logic high. This complementary pairing ensures efficient switching and minimal static power consumption. So what are the operations of CMOS technology? It has logic levels of logic high and logic low. Logic high for one, logic low zero. So when in a in a circuit, when a logic high is typically close to the supply voltage and a logic low is close to the ground. What is the switching mechanism? Yeah, NMOS, when the circuit conducts when the gate to source voltage exceeds a threshold, allowing current to flow from drain to source. In PMOS context, when the gate source voltage is below a threshold, allowing current to flow from source to drain. For that, basic building block of CMOS logic is the inverter, which consists of one NMOS and one PMOS transistors. When the input is high, the NMOS is off and PMOS is on, resulting in a low. Vice versa. When the input is low, the NMOS is on and the PMOS is off, resulting in a high output. So what are the advantages of CMOS technology? Low power consumption, high noise immunity, where the nature of CMOS logic provides inherent noise immunity, and the scalability allows for the scaling down of transistor size, enabling high integration levels and faster switching speeds. There's a wide application where CMOS is used in CPUs, microcontrollers, memory chips, and various digital analog circuits due to its versatility and efficiency. What is the fabrication process? The building process of the CMOS. Well, for first, the process begins with a silicon wafer. Then a thin layer of silicon dioxide is grown on the wafer to act as an insulating layer. Then the thin layers of polysilicon for gates and metal and insulating materials are deposited on the wafer. And photolithography techniques are used to define patterns on the wafer where unwanted materials is then etched away. After the unwanted materials are etched away, implantation of impurities into the silicon creates regions with desired electrical properties. Then the annealing process is done to activate dope pans and to repair any damage caused during processing. Then the metal contacts are deposited to connect various components. Each chip undergoes a testing process and ensure that it works properly. So CMOS technology leverages the unique properties of complementary MOS transistor to achieve efficient and reliable digital logic circuits. Now, this picture is a cross-section of CMOS, where both the NMOS and PMOS transistors are implemented on the same chip. A P channel is induced on the right and an N channel on the left for the P and N channel devices. In the arrangement which we are seeing, the PMOS transistor is carried out directly in the N-type substrate, and the NMOS transistor in a P-type region commonly referred to as a P-well, where the well is a significant low doping level deep diffusion that functions as a substrate for one device and offers isolation between the two device types. Now, coming to the components of a CMOS image sensors, what are the components it contains? What components does a CMOS image sensor contains? Let's see. First, it contains a photodiodes. In this photodiodes or photoactive region, the light photons are converted into the electric charges. So it also determines the sensor's light sensitivity, and it contains a micro lens array, which increases the amount of light that reaches the photodiodes. Eh, So The micro lens array is responsible for the amount of light that the photodiode gets. The more the amount of light it gets, the more sensitive the sensor becomes. Then it contains a color filter array. The array is in a Bayer pattern. As you can see, Bayer mosaic filters, which contains red, green, and blue filters in their specific arrangements. There are also other patterns, but they're also used in specialized sensors for specific applications. Now, it contains metal layers and uh, con- interconnects. These metal layers form interconnects between different sensor components and transmits electrical signals from the pixels to the readout circuitry. Then the CMOS image sensors contain transistor circuitry that is pixel readout circuit, which contains reset transistor, source follower transistor, and a select transistor. The research transistor uh, resets the photodiode to a known state before capturing new light. And the source follower transistor amplifies the signal from the photodiode, and the select transistor routes the signal to the output. So the pixel readout circuit is one of the important components in the CMOS image sensors. Then it contains an ADC, which is analog to digital converters and output amplifiers. These amplifiers amplify the analog signal generated by the photodiodes. Then these analog signals, which are amplified, are converted into digital data, that is pixel values, with the help of analog to digital converters. Now, coming to the CMOS image sensors architecture. The given image is one of the architectural diagrams of the CMOS image sensors. As you can see, it is made up of large array of tiny pixels, each containing a photodiodes. These active pixel sensors, they each contain a photodiode and they are arranged in a pixel array. And when light hits a photodiode, it excites electrons, creating an electric charge proportional to the amount of light received. So the amount of light received, the more the charge generated. And later, each pixel also has a transistor that acts like a switch controlled by on-chip circuitry. And the collected charge in the photodiode is amplified by the circuitry within the pixel itself because each pixel contains its own amplifier, which we have learned. This amplification helps reduce noise in the signal, and the then the pixels are not read out all at once. Instead, CMOS sensors use a rolling shutter, reading each row of pixels sequentially, and the amplified signal from each pixel is converted to digital value by a ADC, which is analog to digital converter, and this digital value represents the brightness of the pixel in the final image, which is viewed. So this is what we learned from the architecture. Now, coming to the block diagram representation of a CMOS image sensor, the working principle, which is viewed in a block diagram. As you can see, it is a two-dimensional array of photodetectors, which is used to sense the instant light intensity. The charge created by a photodetector is then converted to a voltage signal and passed on to the output amplifier to an array of row select and column select switches. Then the ADC is used to digitize the amplified signal. But to perform the readout, the pixel values of a given row are transferred in parallel to a set of storage capacitors, and then these transferred pixels values are read out sequentially. Applications of the CMOS image sensors. They're used in consumer electronics like smartphones or in cameras. In the automotive industry, they're used in ADAS systems or in rear view cameras of the cars. And they're also used in medical fields like as in medical imaging techniques. And they're wide used in industrial inspections and in robots and in robotical field. They're also used in security and surveillance cameras. Moving on, CMOS image sensors in smartphones. Due to their smaller size and low power consumption, the CMOS image sensors are favorable rather than CCDs, which are charge coupled devices. and they also give better image quality when compared to CCDs. And, and the CMOS image sensors have witnessed a significant growth due to the increasing demand for high quality camera solutions in smartphones. And the multi camera setups have also been the main reason for the mass usage of CMOS image sensors in the market. And in the future, we may see an integration of AI enabled features which are integrated in the CMOS image sensors, which can further enhance the capabilities of mobile phone CMOS image sensors. Moving on, CMOS image sensors in cameras. Complementary metal oxide semiconductors are used to create images in digital cameras, in digital video cameras, and even in CCTV cameras. The size of the camera sensor is considered one of the most important factor which can determine the overall camera performance and even the image quality and its definition too. And the factors which are considered while choosing a CMOS image sensors is the resolution, the high frame rate, and the global shutter, the sensitivity, and the lens mount selection, and the image circle diameter are also considered while choosing the correct CMOS image sensors for the camera. This is a typical CMOS camera layout. As you can see, first, the photons which comes from the image are converted into the electrons. Then the electrons, which is nothing but a collected generated charge, is collected and then given as a signal charge. This signal charge is redirected or moved to the detecting node. This detecting node converts a signal charge into electrical signal, which is nothing but voltage. And the ADC analog to digital converter converts the voltage into some digital value, which is used as an image data and to retrieve the image. This is the mono and color spectral response of the CMOS image sensors. There are two charts. The left one is for the mono sensor spectral response, and the right one is the RGB, which is red, green, and blue color response. The x-axis of the graph contains the wavelength, which is in millimeters, and the y-axis is the quantum efficiency of the image sensor, which is given in the percentage. The majority or most of the machine vision cameras have IR cut filters installed installed where they block the near infrared wavelengths. This removes the IR noise and the color crossover from the image, matching how the human eye interprets the colors. However, most of the applications it can be beneficial to image without the infrared cut filters. Whether or not an infrared cut filter is installed, a color sensor will never be as sensitive as the mono sensor. The higher the quantum efficiency, the better the sensor is at sensing light. And the graphs which are given have one of the many performance results based on the measurement standards of the EMVA 1288. The EMVA 1288 standard dictates how to test and display the performance results so that the user can better compare and contrast models across vendors and buy the most suitable image sensor for the camera building. Medicinal field, the CMOS image sensors are widely used in the medicinal field by offering significant benefits in a wide range of imaging applications, which includes endoscopy, where a tiny camera is used to examine the internal organs of the human body. It's also used in dentals, where dental X-rays like panoramic and cephalometric imaging, providing clear and accurate views of teeth and jaw structures. It's also used in robotic surgery, where the robots are integrated with CMOS sensors, giving surgeons a magnified and high resolution view of the operating field. Even in spectral imaging, some CMOS sensors are used to capture images beyond the visible spectrums, allowing for potential applications in disease diagnosis and treatment monitoring. So, why the advantages of CMOS in medical imaging are its low power consumption, faster frame rates and readout speeds, compact design, and the integration with electronics is a huge help where on-chip processor for faster image processing and analysis can be integrated on the CMOS. Coming to one of the best application of CMOS is the X-ray machines. In a typical X-ray machines, we use an X-ray tube and a field detector to detect the image from the X-ray and to convert it to capture the images of bones, organs, and other internal structures. X-ray machines have a wide range of uses in diagnosing and monitoring medical conditions like fracture diagnosis, chest X-rays, dental X-rays, and monitoring arthritis. This is a common X-ray machine which operates based on the principle of X-ray imaging, which uses electromagnetic radiation to create images of the inside of the objects, such as the human body. In this, the X-rays are produced within the X-ray machine by an X-ray tube. This tube contains a cathode and an anode within a vacuum tube. When high voltage is applied across these electrodes, electrons are accelerated from the cathode to the anode. Then the electrons strike the anode material with high energy, and this collision results in the release of X-ray photons. The energy of these photons depends on the accelerating voltage applied to the X-ray tube. The X-ray photons form a focus beam that passes to the object being imaged, like a patient's body part. The X-ray beam is collimated that is narrowed down to ensure that only the area of interest is exposed. As the X-ray beam passes through the body, some photons are absorbed by the tissues, while others pass through. Tissues with higher densities, such as bones, absorb more X-rays and appear white on the resulting image. Less dense tissues like muscles allow more X-rays to pass through and appear darker. The X-ray photons that pass through the body are captured by a detector positioned on the opposite side of the patient. Modern X-ray machines mostly use digital detectors such as flat panel detectors. Then they convert the X-ray photons into electrical signals. These signals are then processed by a computer to create the digital image, and the resulting digital image is displayed on a monitor for interpretation by the radiologist or physician. The image shows the internal structures of the body part being examined, allowing for the detection of abnormalities like fractures, tumors, or other medical conditions. Uh, but most of the X-ray machines will also come with CMOS sensors. CMOS image sensors represents a modern approach to X-ray imaging technology. These offer advantages over the traditional imaging methods such as improved image quality, lower radiation dose, and enhanced efficiency. Coming to the working of a X-ray machine with CMOS image sensors, it's typically the same as a typical X-ray machine. But here, the only difference is that instead of a field detector, it will contain a CMOS image sensor, which uh, which captures the image from the X-ray. Here the X-ray generation is same. X-rays are produced using the X-ray tube. Later, the X-ray beams interact with the tissues. The dense tissues like bones absorb the X-rays, and the softer tissues like muscles and organs let pass the X-rays. The image captures the CMOS image sensor is positioned behind an object being imaged. When the X-ray photons strike the sensor, they create an electron hole phase within the photodiodes of the sensor pixels. The amount of charge generated in each pixel is directly proportional to the X-ray intensity at that point in the body. Then from that, the signal is processed and accumulated in the CMOS pixels and are read out and converted into digital signals. These signals are then processed by imaging systems electronics to construct a detailed digital X-ray image. The resulting digital X-ray image is displayed on the monitor for interpretation by radiologists or physicians. And the image shows the structures within the body and highlights bones, organs, and abnormalities such as fractures, tumors, or infections. This is a representation of the X-ray with a CMOS sensor. As you can see, the X-ray falls on the hand, and from the screen, the CMOS sensor grabs the image from the X-rays and converts it into a digital read for the system. Uh, though the CMOS sensors contribute reduced radiation dose, it is advised to use safety protocols uh, to minimize unnecessary exposure to X-rays and ensure the patient's safety. So, what are the advantages of CMOS in X-ray machines are lower noise, resulting in a clearer and more detailed images, higher efficiency, as CMOS sensor require less exposure to X-rays to produce quality images, which reduces the radiation dose to patients, and imaging speed, that is the capturing of the images speed is rapid, and it improves the workflow and patients throughput in healthcare settings. This is a presentation of the CMOS image sensors. Thank you.